Day 19 of cracking 500 AI and data science interview questions challenge. 5 questions a day, 100 days. If you are new here, don't forget to check out the first 18 days in the playlist. You might have missed some key questions that will be important cracking your next interview. Today's session focuses on real world AI data science challenges that go beyond basic definitions. We will tackle deployment, scaling, monitoring, and practical coding problems you can face on the job. How could you scale an ML model to handle millions of requests per day? Scaling an ML model to millions of requests involves a combination of architectural choices and optimization techniques. Use a high performance serving framework like TensorFlow Serving, Torch Serve, or Fast API plus ONNX for low latency interface. Horizontal scaling, which deploys the model on multiple servers or containers behind a load balancer like NGINX or Kubernetes Ingress. Batch predictions for certain workloads to reduce overhead. Model optimization, which is used for quantization, pruning, or distillation to reduce computational cost. Edge inference for latency sensitive tasks, processing some predictions on user devices. Catching predictions if the same queries appear often. An interview show that you understand both infrastructure, KI, Docker, cloud autoscaling, and algorithm levels optimizations. What is a shadow deployment in ML? Shadow deployment is a technique where your ML model runs alongside the existing production model but doesn't serve live results to users. Instead, it gets the same input data, generates predictions, and logs them for analysis. This allows you to compare performance against a live model without risking prediction quality. It's useful for detecting unexpected model behavior in real traffic, comparing inference latency in a real environment, collecting drift metrics before going live. In short, it is like a dress rehearsal before the main show. Explain the concept of A/B testing for ML models. A/B testing in ML is running two or more models in parallel on live traffic and splitting user requests among them to compare performance metrics. There are some steps that you need to follow. Start with randomly assigning users, for example, 50% model A, 50% model B. Followed by that, measure business metrics, conversion rate, engagement, accuracy, revenue lift, and much more. Third step is perform statistical significance testing to ensure differences are not due to chance. As a final step, roll out the better performing model fully. The common mistake is only tracking accuracy. Real A/B tests track impact on business KPIs. Given a list of user query timestamps, find the peak hour with the most requests. We import counter to count occurrences and date time to parse timestamps. Timestamps contains raw string timestamps. We extract only the hard part from each timestamp using datetime.striptime.har. We use counter to find which hour occurs most often. Here, most common of one returns the hour with the highest frequency. Write a program to count the number of unique words in a paragraph. Convert text to lowercase to avoid case differences first. Remove punctuation, here just periods. Split into words using dot split. Convert list to a set to remove duplicates. Count length of set to get the number of unique words then. When solving interview problems, think loud. Here's your day 19 dose of insight. Verbally walking through your approach, even before coding, helps the interviewer understand your thought process. Many candidates fail not because their final code is wrong, but because they never explain how they got there. Treat interviews as a collaborative debugging session rather than a one way test.